Greetings to everyone. Today in this class we are going to discuss about the resultant stress, calculation of resultant stress, that is due to direct stress and the bending stress. What could be the final result? Okay, now that is resultant stress that we are going to calculate for the column if the load is eccentricity about both the axes, both x and y axis. Okay, so last class we have discussed that the load is eccentricity about any one axis, then we have calculated the resultant stress. Okay, and today's class we are going to discuss about the load is having eccentricity about the both the axes, that we are going to discuss by this class. Now let us move on to the topic. Resultant stress when a column of rectangular section, rectangular cross section, is subjected to a load which is eccentric to both axes. Okay, so first of all consider a column of cross section breadth b and the depth d. So this is about x axis and this is about y axis. Now the load P is acting with an eccentricity at both the axes. Okay, so that about x-axis the eccentricity is Ex, and about y-axis the eccentricity is Ey. Okay, similarly the column cross section is A, B, C and D. Okay, so from the figure, if there are four quarters, okay, so here it is positive, here it is negative, and here it is okay. So this is about our sign conversion that we are going to use it. Okay, so the load is acting at an eccentricity of Ex and Ey about the x-axis and y-axis, and it is concentrating at the first quadrant. Okay, why I am telling this word means if the concentration is going to change, okay, when the breadth, okay, here it is with respect to this, if I'm going to take this is 0 comma 0. Okay, now this one is b by 2 we can have. Okay, now and here it is minus b by 2. Similarly, with respect to x-axis, this is plus d by 2. Here it is minus d by 2, this corner. Okay, and here it is plus b by 2, comma minus d by 2. Similarly, here it is minus b by 2, comma plus d by 2. Okay, so why I am telling this quadrant means based on this only our maximum and minimum stress is going to be calculate. Okay, which means the maximum stress at C, that is at C we can have maximum stress, at A we can have minimum stress. Okay, now, and with respect to this the position B and D, we can have the sign conversion with respect to the uh, coordinate. Okay, now let us move on to the solution part. So first we should move on to the resultant stress formula. Okay, a column of rectangular section, a column of rectangular section ABCD is subjected to a load which is eccentric about both the axes, about both the axes as shown in figure. Now let us consider the some terminologies. P is equal to eccentric load on the column. Eccentric load on the column. Okay. Ex is equal to eccentricity of load about x axis. Similarly, Ey is equal to eccentricity of load about y axis. Okay. Breadth B is equal to width of the column. Width of the column. D is equal to depth of the column. Okay. Then we all know that sigma naught is equal to direct stress. Direct stress, which is equal to P by A. Okay. Next, sigma B is equal to bending stress. So sigma Bx is equal to bending stress about due to eccentricity Ex. Similarly, sigma By is equal to bending stress due to eccentricity Ey. Okay. Therefore, Mx is equal to moment of load about x axis. Okay, such that P into Mx is equal to P into Ex. Similarly, My is equal to moment of load about y axis. So here My is equal to P into Ey. So this is the constraint. Okay. Now the moment of inertia. Now the moment of inertia about both the axes. Moment of inertia about x axis, that is Ix is equal to Bd cube by 12. Bd cube by 12. Similarly, about y axis is equal to B cube d by 12. So this is the formula we can have with respect to the moment of inertia about their corresponding axis. Okay. Now eccentric load is equivalent to a central point load P together with the bending moment P into Ey is about y axis and P into EX is about XX axis is acting. Okay, now therefore the direct stress sigma naught is equal to P by A, that is load by area. Second one, the bending stress, the bending stress due to eccentricity, EY in YY axis. Okay, sigma B is equal to M. Our regular formula is M by I into Y, correct? So instead of that, what we are going to say now, sigma by, that is with respect to YY axis they said. So sigma by is equal to MYY by IYY into x. So here the corresponding distance is with respect to this, okay, with respect to this axis, okay, perpendicular axis. So ex into x, okay. So whereas myy or my is equal to p into ey, therefore sigma by is equal to p into ey into x divided by Iyy. Okay, so this equation, so x is depends upon b by 2 value. Okay, so x is depends upon b by 2 value. The b by 2, why I am saying now, so with respect to this axis, the b by 2 is increasing and the b by 2 is decreasing. Since this is plus b by 2, here it is minus b by 2. So now we are going to set the limit. So is depends upon plus or minus b by 2, or else we can say the x is varies from minus b by 2 to plus b by 2. Okay, next, the same equation, the above equation due to eccentricity ex, so the equation going to change it as ebx is equal to mx by ixx into y. Okay, so here sigma bx is equal to mx, instead of mx we are going to write p into ex. So p into ex divided by ixx into y. Okay, so this is the bending stress value about eccentricity ex. So here y is depends upon d by 2. Okay, so here it is increasing with respect to positive sign. If I am going to downward, then it will get decreasing. Okay, so plus or minus d by 2. Okay, so that y is varies from minus b by 2 to, sorry, minus d by 2 to plus d by 2. Okay, therefore the resultant stress therefore the resultant stress due to eccentricity or due to any point on the section due to any point on the section is equal to sigma is equal to bending stress plus or minus sigma bx plus or minus sigma by. So this is our resultant stress equation. Okay, now we have to calculate with respect to its position a, b, c and d. There are four positions. Now with respect to that position we have to calculate the sigma value, resultant value. Okay, so here the equation going to change it as b by a plus or minus my mx into y divided by ixx plus or minus my into x divided by iyy. So this is the resultant stress. Okay, mr sigma r. So this is the resultant stress equation. Okay, now consider the position A. So here both the things are in negative, that is b by t is also negative, d by 2 is also negative, so that the coordinates x and y are negative. The resultant stress will be minimum right now. Okay, so consider the position A. the coordinates the coordinates of x comma y, that is minus b by 2 comma minus d by 2, are in negative, therefore sigma value will be, sigma r value will be minimum. Okay, next consider the position C. Okay, C. So here both b by 2 and d by 2 are in positive, so that the stress will be maximum. Okay, so here okay, the coordinates of x comma y are in positive, therefore sigma r will be maximum. So the formula is sigma r is equal to sigma naught plus sigma b, sorry, here it is sigma minus sigma bx minus sigma by with respect to position A. With respect to position C, the sigma r is equal to sigma naught plus sigma bx plus sigma by. So all the value will be positive. Next, third one, consider the position B. So here the b by 2 is positive and d by 2 is negative, that is x-axis is positive and the y-axis is negative. Okay, so that the value of x comma y coordinates, that is plus b by 2 comma minus d by 2. Okay, so it depends upon x comma y. Okay, so y value is in negative. Okay, therefore sigma r becomes sigma naught plus sigma bx minus sigma by. So the equation becomes p by a plus mx into y, sorry, okay, y value is negative. Okay, so this value becomes negative. Okay, so mx into y divided by ixx plus my into x divided by iyy. Okay, so next to that, fourth one, that is with respect to position D, that is x value is negative and y value is positive. Okay, so consider the position D. So here the coordinates x comma y are, so minus b by 2 comma plus d by 2, such that x value is in minus and y value is in plus. X value is in negative, therefore sigma r is equal to sigma naught. Okay, x value is in negative, so this one sigma naught plus sigma bx minus sigma by, such that the equation will change as p by a plus mx into y by ixx plus, sorry, minus my into x divided by iyy. So this is how our resultant uh, stresses for the load eccentric about both the axes.